We're surrounded by all this amazing technology that just works. But behind the scenes, behind the flawless streaming and the instant data, there are these tiny components fighting a constant invisible battle just to keep everything running smoothly. Today, we're going to meet one of the most important yet unsung heroes in that fight. Oh, you know that feeling? It's that moment of just pure frustration. Your smart home sensor is giving you a bizarre reading, a really important file just won't open, or there's that weird, unexplainable hum coming from your audio system. You check all the cables, you reboot everything, but it feels like there's a ghost in the machine. Turns out, the cause isn't what you think it is.
Will that ghost? It has a name: electrical interference. See, our sensitive data signals, they're like whispers in a super crowded, really noisy room, and they're constantly at risk of being drowned out by this invisible storm of energy. And that storm, that's the real source of so many of our tech headaches.
All right, so let's properly define this villain we're up against. We are living in a world that is just saturated with what engineers call electromagnetic and radio frequency interference, or EMI and RFI for short. The easiest way to think about it is just as electrical static or noise.
And this noise, it comes from literally everywhere. The power cables running right inside your walls, the Wi-Fi and cell signals that are zipping through the air all around us, the electric motors in your fridge or your AC, and even just simple static electricity. All of these things are essentially shouting over the very delicate data signals that we rely on. So, to protect those whisper quiet signals, you're going to need a hero. And in the world of high-performance cabling, that hero is a surprisingly simple, uninsulated little wire that most people will never ever see. And this is it, the drain wire. Its job is so elegantly simple, it's brilliant. It acts as a dedicated pathway to drain all of that unwanted electrical noise away from the important data, channeling it safely to the ground where it can't do any harm. Okay, think of it this way. A cable's foil shield all by itself, it's kind of like a flimsy fence. It's super thin, it's fragile, and it's really difficult to connect securely. But when you add the drain wire, you transform that flimsy fence into a complete grounding system. It's not a fence anymore. It's a fortress with a moat, giving you a solid termination point to get rid of all that noise for good. This little wire basically acts as a bodyguard, and it undertakes several missions all at once. It's not just a passive piece of wire, it's a multi-talented protector that's performing several critical jobs simultaneously. It's got a 4-part mission. First, it provides a solid ground connection for that fragile foil shield. Second, it actively drains away all that EMI and RFI noise it catches. Third, in more powerful systems, it actually equalizes voltage to prevent electrical stress on the cable. And finally, it stops static electricity, that little zap that can absolutely destroy sensitive electronics. It's the whole protection package. So where does this actually matter in the real world? I mean, this isn't just some abstract engineering concept. This unsung hero is working hard right now in systems that you and I rely on every single day. In your smart home, it's making sure your sensor data is accurate. In a huge factory, it's preventing critical data loss that could shut down a whole production line. In a fire alarm system, and this is a big one, it's stopping false alarms. It even protects the giant motors that run our infrastructure. And yeah, it keeps the internet running fast in massive server rooms. It is everywhere. But, and this is a big but, like any powerful tool, you have to use it correctly. For all these critical jobs, there is one non-negotiable rule. And getting this wrong doesn't just make the wire useless. It can actually make the whole problem a lot worse. So let me ask you a question. Logically, it seems like connecting the drain wire to the ground at both ends of the cable would give you double the protection. I mean, more grounding has to be better, right? It's a really common assumption, but it is one that leads to a major, major problem. Yeah, that assumption is completely wrong. Connecting both ends creates the drain wire's arch nemesis, a really nasty thing known as a ground loop. So, a ground loop basically turns your entire cable shield into a giant antenna. See, the ground potential at one end of a building can be slightly different from the other. It's a tiny voltage difference, but it creates a current that flows through the shield. This makes it broadcast and, worse, absorb electrical noise, injecting it right back into your system. It completely defeats the entire purpose of the shield, which is why the ironclad rule is you ground the drain wire at one end only, and typically that's at the source panel. Okay, so let's zoom out for a second. We've been focused on this one tiny component, but it's really part of a much bigger concept that makes our entire technological world possible.
The whole guiding principle here is something called electromagnetic compatibility, or EMC. It's this simple but crucial idea that all of our electronic devices have to be able to coexist and operate correctly in the same environment without messing with each other. The drain wire, it's a frontline soldier in the war to maintain that electronic peace.
Our modern infrastructure, from our smart buildings to our industrial plants, it's all one complex ecosystem. And its reliability depends entirely on countless small, unseen details, just like the proper termination of a single drain wire, with all of them working together in perfect harmony. So the next time your Wi-Fi is perfect or some complex system just works without a single hitch, maybe give a little thought to the invisible heroes working inside your walls. It really makes you wonder, what other tiny, brilliant components are out there, silently making our world turn?